Hello, my name is Jared Wheeler. I'm here to talk to you today about signal strength threshold. This is a setting in the upper left of the InSpec software. Right now it's set 10%, which is the default for your system. What this is the signal to noise ratio for the measurement. So it blocks out anything with too low of a signal, too little return to the camera, and only accepts, in that respect, high quality data to the camera, enough signal back to become high quality. So in this case, let's just demonstrate this real quick. So we have a random blade here with a pit. The key here is that I'm measuring off the edge. So let's go here. Give it a second. So as you would expect, I got the pit, I got the surface off the edge into open space. I don't get any return back to the camera on the bottom right there in the data set. Now that's because the stray reflections or any kind of noise in that area was blocked by the software before it could be accepted in the data set. So that's really what happens if you don't do that, don't use thresholding. So I'm going to set this to 1% and recalculate. And what you're going to see is that there's some noise in the bottom right now. What that is the really low return stray reflections coming back into the system. Now if you have something that's pretty smooth, which has less scattering reflection, like say this painted clear-coated part here, saw, I can measure it. And here it is with 10% setting. There. Give it a second, and you can see that my measured view, clear I'm in focus. I have green in the part marking area where I measured a 2 here. Part marking. You can see it's in focus, but around the edge it's in focus, but there's a lot less data, a lot less green. So typically with machine surfaces like you're used to, you would see a full field of green and it's all good data. Here, it's still in focus, but the data is a lot more sparse coming back to the camera. So the thresholding is actually blocking all that data from being accepted. Now in this case, because I know the data is good, I know I'm focused on the surface, I can actually lower the threshold to 1% and recalculate, and then I'll get the data I need. So that brings us into the general rule of thumb. For the vast majority of data sets, you can use the default, which is 10%, and that gives you, it blocks out any kind of stray reflection from measuring the open space, what have you. And you get the data you need. But on the off chance you have something that's, say, ultra smooth, like in this case painted or clear coated or something where there's a lot less scattering light, and you know you're focused on the surface, you can see green, some part of it, maybe it's more sparse, but you can see green, you can lower that setting to 1%. So either 10% or 1% is a good rule of thumb for using the thresholding. And one final thing, so for, let's say you have a data set, you want to know what kind of signal strength you're actually getting off that data set. Do I need to lower the threshold? Do I not? What that is, you can go to the contour plot and then go to quality metrics. The signal strength is populated over here. So for the low return one, I got 5%, which is kind of expected. And then for the high return one, or the normal part, I got 54%. And keep in mind, 70% is about as much as you'll ever get. So 54 is actually quite good, and a general rule of thumb, or anything over 20% typically has pretty decent return. When it starts getting 10%, 5% or less, then, and you know you're focused on the surface, then you can start wondering about lowering it to 1%. So either 10% or 1%, right? So that covers signal strength threshold. Please contact 4D Technology with any questions. Thank you very much.